Okay, so monoprotic means that it's just gonna go
It's
from
like
one to the
HCl.
other. Okay,
Mm-hmm.
so strong acids are monoprotic,
Mm-hmm.
and then weak acids.
Oh,
H2SO4.
H2SO4 is diprotic. Right?
Yeah.
Because we can get HSO4 and then SO4.
Okay, so, okay.
That's the only
That's why I wrote that on the
diprotic
test.
strong acid.
Okay.
So when you look, what are we dealing with when we're dealing with the proton, right?
Yeah.
So whenever there's a proton to be able to donate,
Mm-hmm.
we know it can
It'll
act as an
donate.
acid. So if there's only HCl,
Yeah.
it's only going to be able to do it once.
Yeah.
Then we get H2SO4. We go, okay, it can do it once, and then it'll still have an H, so it can do it again.
Okay. Yeah, he said on the test he's gonna have one diprotic one. So,
So then we look at this one and go H3. Okay, so
Gonna do
now,
3,
yeah.
okay. So then it starts off in 0.1 molarity of arsenic acid. So it creates, this plus water is H2.
Okay.
That's wrong, but
So what would that minus be?
2.
Just one minus.
1 minus, yeah. And the
And
next
what-
one would be 2.
So a proton is just kind of this idea, like one hydrogen with
Yeah.
a positive charge. So you lose a positive charge, you get a minus.
Okay. So then, okay, so then what do I do?
Okay. So now we have to think of it again. So we say we have this. This guy
Yeah,
in water. And you said it gives us H2. A
O4 minus, yeah.
plus hydrogen. Okay, so we have this one. So what we're really, and then what are you gonna? Then what's gonna happen?
So you
What
start out
reaction?
with, the next one is H2 ASO4 minus.
Oops.
Plus H2O into HASO4 2 minus plus hydrogen.
And then
And then it's gonna be HASO4 2
okay, so let's start here.
Okay, that's fine.
So
So you're sharing it with 0.1 molarity of arsenic acid.
0.1.
Yeah.
That's excess.
So then you subtract x from it,
Okay.
and you add x on the other side because you're starting with 0, yeah. Okay. So then that. It would just be 0.1 minus x and x.
Okay. And
X.
okay. So did you get you got a K?
Yeah. 5.8 times 10 to the negative
I wish I had written down, but because there's a few tricks with these.
30. Really?
I don't
What?
have enough-
Tell me.
One of these, I don't want to say because
You don't want to mess me up.
I don't want to tell you like a shortcut when it's wrong. Let's just go through them and then we can work backwards if.
Okay,
there's
I
an
know
issue.
he has an example.
I had my notebook and I didn't bring it today.
For shame.
So
I'm gonna fail because of
I'll
you.
quit. Actually, I'm not going to tutor anymore. This
Really?
class.
Is it a lot of?
No, just the teacher I tutored for is not teaching anymore.
Oh, that's sad. Wait.
So I'll either try to tutor OChem or
Okay.
just biology.
Okay, this is.
Okay, so here's our K1, right?
Yeah. Yeah.
So our K1 is 5.8 times 10 to the negative 30.
Yeah.
because one of these you can just plug in. Like you can just, because you're gonna start getting like X, Y, and Z, and one of them you could just plug into one of them.
Really?
Yeah. I can't remember. I think it's K2. You can plug into Y or something. Oh well. Let's see. So we have this. 5.8 times 10 to the -30. So then we have to solve it.
So it'd be x squared. That 5.8 times 10 to the -30
So you get an SC.
over x, or x squared over 0.1 because the negative x is
SC quadratic.
insignificant.
Did you do this in class?
Not this one. He gave it to us in class, but he said to do it by ourselves.
Okay.
So, but it's so minuscule that we get rid of the x, right?
Okay. So there's one thing, but you would have, you could just do it, or you could do the check, the 5%. Oh.
Oh, minus 5%, less than 5%.
Has to be less
you
than
can get rid of
5%,
it.
yeah.
How do you do that? I know that rule, but I don't know how to do it.
So we have this.
I mean, it's negative 30, so.
Whoops, 0.1 -6. So yeah, you could look at it and say -30. But let's try to do this real quick.
Yeah, because I need to know how to do that.
So we do this, and we say that we're just making the assumption, right?
Okay.
So we're just gonna say X.
Isn't it just x squared and you get rid of that?
Yeah. So we're gonna say this. So do it, solve it.
Okay. Okay, it's 7.6 times 10 to the -16.
X equals 7.6 times 10 to the -16.
Mm-hmm.
So then you just take this and put it over here, over this guy.
Wait, what?
You just take this,
And you divide it by 0.1?
yeah, and then you get, so you're gonna
Yeah.
get a tiny number.
Yeah, it's still 10.
So it's less than 5%.
Yep.
But that's the idea.
Okay, so you take the x you get and you divide it by what you were dividing it by before.
Because what we want to see is that it's less than 5% of what we started with to
Okay.
be safe.
Okay.
Just doing this assumption.
Okay.
Because if it's less than 5%, the number's so small
That it
that it
doesn't
doesn't affect this guy really.
Okay.
Okay.